Hello, this is MK Adegold. I will take you on selection of lag selection criteria and co-integration tests. Once again, I will take you on lag selection criteria and co-integration tests. Co-integration tests. Co-integration, we normally perform co-integration to determine if two variables have long-run association. Repeat, we perform co-integration tests to confirm if two variables have long-run association. That is, if in the long run there is a long-run equilibrium. Okay. To do that, we will perform what I call lag selection criteria for these variables. We have exchange rate, we have export, exchange rate, and inflation rate. These are the three variables we'll be using. We'll open them as a group. These are our variables from 1986 to 2017. We have exports, exchange rate, and inflation rate. These are the variables that we'll be using to perform our lag selection criteria and co-integration test. First, the lag selection criteria. The lag selection criteria is performed by going to view. Go to var estimate. This is the var dialog. Come over here where they wrote endogenous variables. You type in your variable as you want them to appear in the var model, which is export first, graph space, exchange rate, we have inflation rate. These are the three variables we are using, and we leave it at two lag interval. We are performing lag selection criteria. As you can see, this is the lag interval for endogenous variable, but here we want to know the lag values that we'll be selecting. We'll click OK. This is a var model, a var estimate. We are not concerned with this var estimate. All we are looking for is just the lag selection criteria. You go to view, go to lag structure, click lag criteria, let's select 8 as our lag selection criteria, click OK. 8 is a long variable. Lag structure, put 4. This is where we are. These are the lag selection criteria. You can see var lag order selection criteria. Endogenous variable have export, inflation, exchange rate, and inflation rate. These are criteria in selecting lag values. The most popular ones are AIC, which is ACK information criteria, Schwartz information criteria, and Haneke information criteria. So the three most frequently used information criteria that most used. As you can see, even all the lag selection criteria are selecting 1 as our lag value. Now you can see this is the lag value. These are the criteria of selecting lag value. The most prominent three that were mentioned earlier are all of them select 1 as our lag selection criteria. These are our lag. That means we selected 1. You can see this asterisk. This asterisk shows that they all selected 1 as it is indicated here. Asterisk indicate lag order selection selected by the criterion. This is how to perform lag selection criteria. Again, you go to view, then go to lag structure, then you go down to select lag selection criteria. Now, if you note that with know our what? Our selection criteria. We've known our what? Our criteria, which is 1. Our lag selection criteria is 1. Now to perform a cointegration test, we'll come over here, click view, come to cointegration test. This is cointegration test. Go to Johansson cointegration test. Click OK. Remember, we perform a lag selection criteria and it gave us what? 1 as our last selection criteria. So we'll select 1 as our what? Last selection criteria. These are other criteria to select. This is what assume that no trend and no trend in the data. It is advisable to go with 3, but let's try 3 and 4 and see. Let's try 4 and see. Let's try 4 and see. As you can see, this is the output for what? Lag selection criteria, and it's showing us that there is no cointegration. Well, let's go back with 2. Let me select 3. The same thing is showing us that trace tests indicate no cointegration at 5% level of significance. To explain this, let me open it up. To explain it, this is what? A cointegration test, Johansson cointegration test. How do you know if there is cointegration? This is how to know if there is cointegration. This is a null hypothesis. We have 2 boxes here. We have 2 outputs here, or probably 3. This is the first one. Unrestricted cointegration rank test, trace test, which is trace test. The second one is unrestricted cointegration rank test, maximum aging value test. These are the 2. Then also we have the normalized cointegration coefficient, which are this one down here. So this one down here. But what we are concerned with is with these 2 first. Let's explain these 2 cointegration output. Now, cointegration simply means there's 2 variables or 3 have long-run relationship, and the null hypothesis here is saying that null hypothesis that there is no cointegration. This is CE, cointegration. There's no cointegration, and the selection criteria here is this P. Whenever this P value is less than 5%, we will reject this null hypothesis. If the P value here is less than 5%, we will reject the null hypothesis. That is we reject the null hypothesis. But here, as you can see, the null hypothesis cannot be rejected. Look at the maximum exit value is greater than also the T statistics, and sorry, is greater than 5%. So trace statistics here 25 is less than critical value, and also it is supported by what? By P value, which shows us that there is no cointegration. But I will repeat, the selection criteria says that the trace statistic here, whenever it is higher than the 5% critical value, then we cannot reject the null hypothesis. But if the reverse is the case, we reject the null hypothesis. Look at 25. This is 25.03 is less than the 5% critical value. Therefore, we cannot reject this null hypothesis. That means there is no cointegration for the first one, and it's supported by what? By the P value. Likewise, the second one, at most, the second null hypothesis at most 1 cointegration. Look at the trace statistics, which is 5.792. It's less than what? It's less than 15.49, and it's supported by what? The P value. Therefore, we cannot reject the null hypothesis. Means that there is no cointegration, that at most one cointegration. Cannot reject this hypothesis. That means there is no cointegration. Yeah. Also, to support this, likewise the second one, this one also, at most two cointegration. Look at this value is less than this particular critical value. Therefore, it's also the maximum exit value support our theory. If you notice, the maximum exit value also, the maximum exit value is less than the critical value at 5%, supporting our the trace statistics. Means that there is no cointegration. And also, you can also check it down here. It says trace indicate no cointegration at 5% level. This is all that matters here. It will always show you a trace statistics indicate no cointegration. Likewise, maximum exit value indicate no cointegration at 5% level, meaning that there is no long-run relationship among these variables. There is no long-run relationship among exchange rates, exchange rate and inflation rate. The other aspects to explain is the normalized cointegration coefficient, the standard error, which are in parentheses. Here, the reverse is the case here. We can also use this to do our thesis or our dissertation or paper that you are writing. You can also use this normalized cointegration to explain your result. Here we can see that export is our dependent variable, exchange rate and inflation rate are our two independent variables, as you can see. But remind you, if you are using the normalized cointegration coefficients to explain your regression, please convert this particular exchange rate, which is positive, to negative. Also convert this inflation rate to negative, meaning that if I want to explain this now, I will say a 1% change, a 1 unit change in inflation rate will result to about 0.04% decrease in what? In export. I repeat, a 1% change in exchange rates will result in about 0.0% decrease, sorry. This is positive here, this is positive, but you change it to what? To negative, decrease in export. Likewise, a 1 unit change in inflation rate will result in 17% change in what? Export. Please, you convert this figure, you reverse them to negative sign. You reverse them to negative sign if you are using normalized cointegration to explain your dissertation. Meaning that from here, these are the question we use as a normal regression to explain what? To explain your regression analysis. I hope this tutorial kind of open you up to the rudiment of the cointegration test and lag selection criteria. Please, if you have any question pertaining this, please don't hesitate to ask me. You can send it in my mailbox. I'll be able to do another video that will cover those aspects. But I believe with this, I try to make it as simple as possible in explaining the cointegration test and the normalized test. Please, as I said, we normally check down here to check if there's cointegration. You can see there is no cointegration. It will give you the straight answer. There's no cointegration. Therefore, since there's no cointegration here, if you want to proceed and you don't want to, if you want to proceed, maybe you don't want to use the normalized cointegration coefficient to do your dissertation. You want to move further. These variables you can only use VAR model. Why? Because there is no cointegration. And even there is cointegration, we'll use VECM. But being that there is no cointegration here, this model we can only revert to what? Using VAR estimate. Using VAR estimate to do your dissertation. Thank you. God bless you. Till I hear from you. Bye.